this is actually this distribution was first defined by Mr. W.S. Gossett. And why the name was given student? Because at those time, at those years, they are not in which company they were work for. They are not allowed to give their own name to publish any writing. So that is why the Mr. Gossett published the distribution and then by the name of student. So student's t distribution is one of the sampling distribution of mean. So when the if a random variable t is random variable is t, and it will follow student's t distribution or simply t's distribution. Student's t and t both are same distribution with the degree of freedom of n. Then the PDF will be like this, that is 1 by root over n, and this is nothing but the constant. This first part is nothing but a constant into 1 by 1 plus t squared by n whole power n plus 1 by 2, where n, n is the number of degree of freedom. N is the degree of freedom, and degree of freedom is the number of observations which are independently we can take to estimate any distribution. That is degree of freedom. And in this t distribution, the distribution is the range of distribution is minus infinity to plus infinity, and it looks like actually it approaches the normal distribution. The normal distribution is a bell like shape, and the t distribution looks like a normal distribution, but with the change of with the change of degree of freedom, with the change of number of degree of freedom, with the change of n, small n, the shape will be slightly different. How? By the height, by the distribution area, by the height. If the number of degree of freedom increases, then the shape will, the height of the distribution of the peak will become flatter, and with the increasing it will become with the increasing of the number of degree of freedom, it will follow the normal population, or its peak will be more. Its height of the peak will get increased. And this area where BPQ, this is nothing but gamma functions equation, gamma P gamma Q by root over P plus, not root, sorry, gamma of P plus Q. So this particular first part is a constant, and this is the function of T. And so this is the probability of a T distribution. So if xi are independent and individual identified variable, then observation from a normal distribution with mean mu and variance sigma square, where the variance sigma square will be unknown, where the variance of sigma, variance of population sigma square will be unknown, then you can students' T distribution can be that distribution focuses on student distribution, students' T distribution. And this the sample variance small a squared is equal to summation of xi minus x bar whole square by 1 by n minus 1. And for sample variance, the degree of freedom always decreased by one unit, and it estimates the sigma square, the population variance. So this is the T distribution. Now the T distribution, how the T distribution is related with z and xi square, that will be, or chi square, that is like this. If z and chi square distribution, already in the last class we taught, that is chi-square distribution is nothing but the z distribution. When we square the z, then that will follow the chi-square distribution. So chi-square distribution and z distributions, when z and chi-square are independent random variables, where z follows the normal distribution with 0 and 1, because z is the standard normal variant, and its mu is 0 and its variance is 1. Then chi square follows chi n square, that is with number of if you add more n number of z1 square, then that will follow the chi square will also follow the chi n square. Then t will be equal to z by root over chi square by n. Now this is by n is the number of degree of freedom, and z is the z variable, and the chi-square is the chi-square independent random variable. So this is the relation between t, z and chi-square. And if x1, x2 to xn be the independence variable that follows the normal distribution of mu and sigma square, where sigma is unknown, then t will be x bar minus mu by s by root over n. Because when you do not know the sigma square, then you can estimate the t distribution with small s, with the sample variance, right? So at that case, you can write that t equal to root over n x bar minus mu by s. Like the formula x bar minus mu by sigma by root n. Same formula, with the place of sigma we are replacing with for the place of sigma we are replacing with s. And it's because when you are calling for the sample, then your degree of freedom will be decreased by 1. That is why t equal to root over n x bar minus mu by s will follow the t distribution with n minus 1 degree of freedom. Now, if two independent random samples of sizes n1 and n2 are drawn with replacement from two independent normal population with mu1 and mu2 for the two different normal population, if the means are mu1 and mu2 and the variance are sigma square, both are common variance, there is no sigma 1 sigma 2, the common variance sigma square, and the sigma square is also unknown, then also you can go for this t distribution in this way, where the formula will be t equal to x1 minus x2 bar minus mu1 minus mu2 by because the standard formula is this. This is the standard formula, and when you will take the sample from two different, when you are taking two different sample size, then for two different degree of freedom n1 and n2, then your t will be by following the standard formula x1 bar minus x2 bar minus mu1 minus mu2 by s root over 1 by n1 plus 1 by n2. And here the degree of freedom will be n1 plus n2 minus 2. This is the degree of freedom. So when you will have this degree of freedom n1 plus n2 minus 2, when you are taking two samples of size n1 and n2 and with replacement. Clear? Is it clear? Actually, you have to follow the formulas. You have to remember those formulas. Anything, any doubt is there? Okay. Then yes. আচ্ছা, বাড়িতে একটু প্র্যাকটিস করতে হবে, বুঝলে তো? বাড়িতে যত প্র্যাকটিস করবে তো অনেক ফর্মুলা মনে রাখতে একটু অসুবিধা হয়। I always suggest you to practice more and more so that automatically you will have the idea, automatically you can remember. And And this is with respect of this situation, we can say the what is the formula of a square. The basic, the standard formula of a square is this, that is xi minus x bar whole square, summation of I equal to 1 to n by 1 by n minus 1. So we if for this case, you can say for the different sample size, we can say for different sample size n1 and sample of size n2, the for two different sample mean will be there, x1 bar x2 pair, and for the different sample value will be there. So x1 I means the sample value of size n1, so it will start from I equal to 1 to n1. And for this for sample 2 for the sample 2 means the sample of size n2, so obviously it will have n2 number of variables. So this is the sample 2 variables x to I, starting from I equal to 1 to n2. So formula is set by the 1 by n minus 1. So for two different sample, but if you take n1 minus 1 and n2 minus 1, to total sample degree of freedom will be what? Sample size will be n1 plus n2 minus 2. Because you know the standard formula is this, and for the individual, for two individual sample, so n1 minus 1 plus n2 minus 1. So n1 minus 1 plus n2 minus 1 will stands for n1 plus n2 minus 2. That is why it is written like this. Clear? And you can say this is nothing but if you these are individuals variance of these two sample. So I can write, if I if this has 1 by n1 and if this has 1 by n2, so we can say this is nothing but s1 square and this is nothing but s2 square. So we can modify this equation like this: n1 s1 square plus n2 s square, right? Because if you just see, if for the first sample, if you write 1 by n1, and for the second sample if you write 1 by n2, so that will nothing but s1 square s2 square. So that is why the equation is modified in this way. Clear? So there are some important properties of T distribution. So in T distribution, we you have to remember the T distribution will be for the sample size small. For smaller sample size means the sample size, when the sample size will be less than 30, then it follows the T distribution. And in T distribution also, you have seen the population variance is unknown. The population variance is unknown. So that is also a property of T distribution. And remember, the population from where you are taking the samples is a normal distribution. The population from where you are taking the sample, that population is the normal population. That is why T distribution follows normal population. And when the number of degrees of freedom will be increased, the T distribution curve will follow the normal distribution. So there are some properties. First property is the T distribution is defined by the only parameter n, where n is the degree of freedom, which is a positive integer. Thus, the distribution is known if n is known. Next, like normal distribution, T distribution is symmetric about 0 because it follows normal distribution. Population is normal distribution, so obviously it will have the same property as normal distribution. That is, it will be symmetric about 0. It will be symmetric about 0. Yeah. And it is leptokurtic. Just see the structure leptokurtic. And T can take any value from minus infinity to plus infinity. It will not touch the x-axis. It will the range will be from minus infinity to plus infinity, but without touching the x-axis. And the mean of t is 0. Expected value of t is 0 and variance of t is equal to root over n by n by 2, n minus 2. This derivation is not required. That is why it is no need to do. Just remember the variance of t is root over n by n minus 2 for n greater than 2. And the distribution approaches, so you can see if you increase the if you increase the degree of freedom, if you increase the degree of freedom, your variance will be increased. It will be more positive. So the distribution approaches standard normal distribution as the degrees of freedom very large. That is why already I told you. In case of distribution, what happens when you suppose for degree of freedom, if your degree of freedom is suppose for example 2, then it will be like this. It will be like more flatter. And if you when you increase your degree of freedom more and more, your peak will be, the height of the peak will be increased. So with the increasing of degree of freedom, the distribution approaches to like normal distribution, because in normal distribution you see it is not, the peak is not flatter, the peak is not flat. But when you increase the degree of freedom in when you decrease the degree of freedom in t distribution, it will get more flatter. But so with the increasing of degree of freedom, the t distribution approaches the standard normal distribution like this, with with more peak. And the random variable t is defined as the ratio of standard normal variate to square root of chi-square variate divided by degree of freedom. So this will be seen. This just see, this is the formula. That is what is written. It will be inverse proportional to root over chi-square. And the notation T alpha n denotes the upper alpha point. This is the alpha is, this is the critical point of this T distribution. This is the negative side critical point. The two tail, for two tail case, these are the critical point of T distribution. And this alpha part is rejected part, whereas this part, this 1 minus alpha part, is the accepted part. Clear? Clear আছে? Okay. Now we are going for F distribution. F distribution is another sampling distribution, but F distribution is the sampling distribution of variance, like chi-square. T distribution was the sampling distribution of mean, whereas F distribution of the sampling distribution of variance. So, if distribution was named after the scientist Sir R.A. Fisher, and it was defined by Snedeker, and that is why its name is Snedeker's F distribution. In previous, it was students' T distribution. At that time, they were not allowed to use their name, but here F distribution was defined by Snedeker, but he gave the then why if this is due to the Fisher, the scientist Fisher. A random variable is said to follow a distribution with n1 and n2 degree of freedom if the PDF is of the form of this. In this form, the PDF will follow in the this is the form of PDF, and the first part is the constant part, and the F distribution, just see the range of F distribution is from 0 to infinity. So it will not, the distribution will not look like this. This will be only, it will start from 0 to infinity. So it will be in the first one, the distribution will be just like this. The first quadrant, the curve will be for the first quadrant. If chi n1 square and chi n2 square are two independent chi-square variable with n1 and n2 degree of freedom, then the F distribution, F will be equal to chi n square, chi n1 square by n1 by chi n2 square by n2, where n1 and n2 are the degree of freedom for these two independent chi-square variables. So from here you can easily find out the relation between chi-square and f distribution. So if this formula is important, f is equal to chi n1 square by n1 by chi n2 square by n2. And if there are two independent random samples of sizes n1 and n2 from two normal populations with variances sigma 1 square and sigma 2 square, then and if s1 square is equal to 1 by n1 minus 1, where summation of I equal to 1 to n1, x1 I minus x1 bar whole square, and s2 square is equal to 1 by n2 minus 1. This formula is known to you. If you want, these are for different sample, but the standard formula was a square is equal to 1 by n minus 1 summation of I equal to 1 to n xi minus x bar whole square. And s2 square will be like this. So for two different normal population, for two different sample, we can say like this. The variance of two different samples will be like this. Then we can say the f will be, if distribution f will be n1 minus 1 into s1 square by sigma 1 square, because s1 square by root over sigma by sigma by root over n. But for the first case, the degree of freedom is n minus 1, so we can say sigma by root over n minus 1. And for the second case, we can say sigma 2 by root over n2 minus 1. So you can write like this. That is n1 minus 1 into s1 square by sigma 1 square by n1 minus 1, and n2 minus 1 s2 square by sigma 2 square by n2 minus 1. So here in both denominator and numerator, you have to divide by the degree of freedom. Then it will be like n1 minus 1, n1 minus will cut out. So and n2 minus 1, n2 minus will cut out. So you will have s1 square by sigma 1 square by s2 square by sigma 2 square. So we can write as a whole s1 square by s2 square into sigma 2 square by sigma 1 square. And it will have the degree of freedom n1 minus 1 and n2 minus 1, because two independent random samples. So that is why the degree of freedom is n1 minus 1 and n2 minus 1. And the different important properties of F distribution is, F distribution is what? It is a ratio of the variance of two samples of size n1 minus 1 and n2 minus 1. Okay. And the distribution is defined by two parameters n1 and n2, which have, they are degree of freedom, so obviously they are positive integer. The mean of F variates with n1 and n2 degree of freedom is, so in F distribution the mean is n2 by n2 minus 1, which is greater than 1, and the variance is 2n2 square n1 plus n2 minus 2 by n1 into n2 minus 2 whole square n2 minus 4. So as the parameters of this distribution has two parameters only, n1 and n2, so you can see for both mean and variance, the expression is with the parameter in terms of parameter n1 and n2. The mean will be exist if n2 is greater than 2. Obviously, because if n2 is less than 2, then the mean will not be, it will get negative. So and mean must be greater than 1. So it will exist when n2 is greater than 2. And variance will be exist if n2 greater than 4. Otherwise, it will be negative value. So for large value of n1 and n2, the distribution approaches normal distribution. When your degree of freedom will be large, then this distribution also approaches normal distribution. And if n1 and n, if n1 equal to 1 and n2 equal to n, then the f distribution reduces to distribution t square. So here the two degree of freedom is n1 and n2. If your n2 will become 1 and n1 will become 1, first degree of freedom will be 1 and the second degree of freedom is n, then it will become the t distribution. Because in t distribution, you know, the degree of freedom is n minus 1 for standard for if it follows the chi-square at z square, and that is why for that case the distribution will follow the t distribution, where t follows t n distribution, that is f1 comma n follow t n square form distribution. So this is very important. When in f distribution, when the degree of freedoms are 1 and n, then it follows t n distribution, where the it follows t distribution with degree of freedom small n. And if f follows if f follows the f distribution of n1 and n2, n1 by f will become f of degree of freedom of 2 comma 1 n2 comma n1. So this part, this number 4, it is very important because this type of question comes in MCQ. So if you're in case of f distribution, if the distribution freedoms are the degree of freedoms are 1 and n, then it will follow t distribution. And this is positive skewed because why? You can see the curve of the f distribution. If the PDF of f distribution is if look like this, and you can see the range of f distribution is from starting from 0 to infinity. That is why in the at the beginning of f distribution it is written the range of f distribution is starting from 0 to infinity. So range is from 0 to infinity. Clear? And this is the f alpha n1 comma n2. This is the critical point of f distribution, and this is the negative side of this is f1 minus alpha n1 minus n2. This is f distribution, and this part alpha is the rejected part, and this is the accepted part. And in f distribution, you can see it is a positively skewed. That is why it is written this is a positively skewed distribution, but the skewness decreases as the degrees of freedom increases. That is why when the degrees of freedom increases, a skewness decreases means it will this peak will come towards the center. That is why it approaches to normal distribution. And there is the relation between these 4 distribution are given. These are all the relation you already already given in the in this distributions, and they here the relations are given so that you can remember easily. So, the relation between z and chi-square, you know, for z and chi-square, what is the relation? For summation of z I square, that is the chi-square. Already আগে দিন বলেছি যদি z1 স্কয়ার হয় তো ডিগ্রি অফ ফ্রিডম z2 স্কয়ার অফ ডিগ্রি অফ freedom 1, z3 square of degree of freedom 1. If you add all these z square, then your that will follow the chi-square, and the chi-square will have the degree of freedom n if you add n number of z square. If you add n number of z square, then the chi-square will follow. Then the chi-square will have the degree of freedom n. That is why this is the relation. This is already known. And now you from the t distribution you get this formula, that the relation between T, Z and chi-square, this is the formula. And the relation between chi-square and F, that is the formula. If the F distribution of N1 and N2 degree of freedom will have equal to chi N1 square by N1 by chi N2 square by N2. This is the relation, and relation between T and F has this relation. What is the relation? If your degree of freedom of N1 will become 1 and N2 become N, then it will be the T distribution with degree of freedom N. It will be T square distribution with degree of freedom N. Clear? So these are the relation between different sampling distribution. And the last part of this chapter is central limit theorem. When the sample size is sufficiently large, the sampling distribution of the sample mean x bar is approximated by normal distribution regardless of the shape of population distribution. Then this is known as central limit theorem. That is, when n is sufficiently large, the sampling distribution of x bar is approximately normal with mean of x bar is mu x bar equal to mu, and standard deviation will be sigma by root n. The sample size large means what? What is called the sample size? That means when the number of samples will be greater than 30. That is called sample size, large sample size. So that is the central theorem. And if x1, x2 to up to xn be the random variables with expected value of sample mean mu and expected value of sample variance sigma square, then z will be x bar minus mu x bar by sigma x bar is nothing but the sigma by root over n, the sample variance. This is written in this way, the sample variance, and x bar minus mu by sigma by root over n follows the standard normal distribution for sufficient large n. তাহলে কি আমরা বুঝলাম? So what is the central limit theorem? Central limit theorem means when the sample size are large, then we the distribution, we approximate the distribution as normal distribution. That is called the central limit theorem. Clear? And the sampling distribution for proportion, that means the binomial binomial distribution. For that case, we can say the sufficient for the large sample size, we can say z equal to p minus expected value of p. Now what is the p? P is the x by n, which is sample proportion of unit belonging to a particular class in a sample size of n. This binomial part you already know. This is before the in the probability distribution, this part already covered. So for sampling distribution of proportion, so we will talk about the sample. So if p is the sample proportion, if p is the sample proportion of that is x by n, then for the sufficient large sample size n, z will be p minus. Why p minus? Because you remember the formula x minus mu by standard deviation by sigma by root over n. Remember the formula? So what is the formula? Remember? If you remember the z formula, what is this is if z is equal to x bar minus mu by standard deviation, right? The standard deviation is sigma by root n for sample. So for binomial distribution also, the x bar minus mu, this is expected value of p means x bar minus mu. So expected value of p is pi. In binomial distribution, can you remember this all? Can you remember this?
Yes, ma'am.
দাঁড়াও আমি একবার শুরুর দিকটা দেখাই, তাহলে তোমরা মনে করতে পারবে। ওই ফর্মুলাটা দেখলেই তোমরা মনে করতে পারবে। এক মিনিট দাঁড়াও, এখানেই মনে হয় ছিল। দাঁড়াও এক মিনিট, দাঁড়াও দেখি কোথায় গেল। এই যে মনে পড়েছে, এই দেখো ফর বাইনোমিয়াল পপুলেশন মনে আছে, expected value of p equal to pi। expected value of p মানে কি, expected value of p মানে আমরা কি বলেছিলাম, p means x by n, sample proportion, then expected variance of p equal to pi into 1 minus p by n. By following the formula x bar minus mu by sigma by root over by standard deviation, we can say this formula like this. By following those formula, by following those formula you can easily write this p minus expected value of p, because z is equal to x bar minus mu by standard deviation, x bar minus sample minus mean by standard deviation. In terms of sample we can say sample minus sample mean by standard error, because standard deviation is for population and for sample standard deviation, standard error of p will be root over pi into 1 minus pi by n. So just for following those formula, we can say this is the standard normal distribution for binomial population. And if for sufficient large sample of size n1 and n2, we can say the z is equal to p1 minus p2 minus expected value of p1 minus expected value of p2 by standard error of p1 minus p2. তাহলে p1 minus p2 তো লিখবো, expected value of p1 means pi1 and expected value of p2 means pi2 by standard error of p1 minus p2. Standard error formula ki pi into 1 minus pi by n. So for p1 it will be root over pi1 into 1 minus pi1 by n, and we know standard variance always added, right? এটা আমরা last class-এ আমি দেখিয়েছিলাম না why it is added. So by following those it will be pi2 into 1 minus pi2 by 8. Clear? So if pi1 and pi2 are the same but unknown, then p will be x1 plus x2 by n1 plus p2, because p is x by n. So for two sample it will be x1 by n1 plus x2 by x1 plus x2 by n1 plus n2. And standard error of p1 minus p2 will be root over p into 1 minus p into 1 by n1 plus 1 by n2, because p into this standard error of p1 and p2 will be like this. If your pi1 and pi2 are not known, if pi1 and pi2 are not known, then you can replace this with p. Clear? And this derivation, this part already আমি দেখবে ডেরিভেশনের যে পেপারটা ছিল ওর মধ্যে রয়েছে, একটু চেক করে নেবেন। Now easy numerical is given. 15% of people in the small community of Stan's Point have type B blood. A random sample of 500 persons is selected. Then what is the probability that the sample proportion of people with blood type B is more than 17.5%, less than 14%, and between 16 and 18%? So very easy. So total number of sample is 500 and the proportion is what? Pi is equal to, দেখো 15%. So that will be 0.15. Pi equal to 0.15. So sample proportion P will be what? X by N, and for the large N, Z is equal to P minus pi by root over pi into 1 minus pi by N. So my question is, what is the probability that the sample proportion of people will have more than 17.5%. So we can write probability of P more than sample proportion. So P means proportion. So here we are not writing Z or anything. We have to write P proportion. P greater than 0.17.5% means 0.15 greater than 0.175. So by using the formula, instead of Z, we can write P minus pi by root over pi into 1 minus pi by n, that is greater than, just put the formula. P is 0.175 minus pi is 0.15 root over pi into 1 minus pi by number of sample, that is 500. So from here we can say that is, this is nothing but a Z greater than 1.57. So Z greater than 1.57 can be written as 1 minus probability of Z less than equal to 1.56, and 1 minus probability of Z less than equal to 1.56 means 1 minus pi of 1.56. So pi of 1.56 is 0.9406. So from here you can get this result. And for the same case, if you have the probability of less than 14%, so you can write so proportion less than 14%. So in terms of proportion, we can write this formula, and this is can just put the value, and you will have probability of Z less than minus 0.63. So it is you cannot write this probability, right? So that you can say 1 minus probability of Z more than this. So we can write 1 minus pi of 0.63, that is this and this are same, and from here you will from the table you just write pi of 0.60, that is 0.7356, and finally you will get this result. And for the last case, same, using the same formula. For the last case, it is in between 16 and 18%. So just put the formula. You will have this. You know how to find out, and this is nothing but this result. So like this, you can find out the probability of different cases. So these are the all about sampling and sampling distribution. And after that, the chapter has all the formulas, whatever you have learned in this chapter. Those are written here for your credit economy. So you will learn those. So that will be beneficial to you to remember individually. And then the exercises are given. So you may see, you may check those. And if you want to know anything on it, if you have any other queries, you can tell me. আচ্ছা, তোমাদের কি স্যার থিওরি অফ এস্টিমেশন বলেছেন পরীক্ষায় আছে?
না, এখনো বলেননি। মানে শুরুতে এই 3টে চ্যাপ্টার দিয়েছিলেন, কিন্তু আলাদা করে বলেননি যে এইটা সিলেবাসে আছে বলে। উনিও পড়াননি ওই পার্টটা।
আচ্ছা স্যার, তোমাদের কি শুধু ফার্স্ট চ্যাপ্টারটা পড়িয়েছেন? আচ্ছা আচ্ছা আচ্ছা, আমাদের তো স্যাম্পলিং ডিস্ট্রিবিউশনটা হয়ে গেল। থিওরি অফ এস্টিমেশনটা আমি জিজ্ঞেস করতে হবে স্যারকে, আদারওয়াইজ আমি থিওরি অফ এস্টিমেশনটা না খুব একটা টাফ নয়। তো এটা আমি যদি স্যার বলেন পড়াতে, তাহলে আমি এটা এগিয়ে দেবো। তোমাদের কি পরীক্ষার কিছু রুটিন দিয়েছে, কবে কি পরীক্ষা?
মানে রাফলি শুনেছি 10 তারিখ থেকে হবে, বাট মানে অফিসিয়ালি কিছু আমাদেরকে জানানো হয়নি, রুটিনও দেওয়া হয়নি, অফিসিয়ালিও জানানো হয়নি। ওটা টিচাররা বলেছেন, এইচওডি স্যার বলেছিলেন, আমার মনে আছে।
ও আচ্ছা আচ্ছা, ঠিক আছে, তাহলে তোমরা পড়ো, আর আমি স্যারকে জিজ্ঞেস করে নেব। যদি স্যাম্পলিং হয় আমি আবার তোমাদের নেক্সট ক্লাস করে যতটা হয়, এবারে এস্টিমেশনটা যদি থাকে নেক্সট ক্লাসে একটা ক্লাসে আমি যতটা পারবো বুঝিয়ে দেবো। ঠিক আছে?
ওকে ম্যাম।
ওকে দেন, থ্যাংক ইউ।
থ্যাংক ইউ ম্যাম।